Alrighty, everybody. So, for those of you who missed class on Friday, due to excused absences or whatever with the storm, or for those of you that were here but thought I went way too fast, which I did. This material is pretty complex, so it's worth watching again. I would go to the slides on Classroom for chemical reactions and find this page. Print it out if you have a computer, or recreate it by hand if you don't have a printer. Backside has the conversion factors that we will generate and talk about. In particular, today we're going to cover moles, the number of particles in 1 mole, and we're going to cover how to find and use molar masses, the mass in grams of a single mole of a substance. For now, we're going to keep on this side. And for today, we're going to worry only about this side. I have A, substance A, whatever A happens to be, and B, substance B. Eventually, we'll be able to change from one substance to another substance. Say I need sodium and chlorine to combine to make sodium chlorine. Well, what mass of sodium do I need to combine with what mass of chlorine do I need to make, on the other side of our reaction on the product side, some amount of sodium chloride. That's the gist of where this will eventually take us. But every arrow here is a conversion. Every time we cross an arrow, we have to convert using a fraction. This is not much more complex than the idea of converting quarters to dollars. Just uses big scary names like stoichiometry and molarity and moles. But in your head, if I said, alright, you have 16 quarters, you can very quickly convert that into dollars for me. 16 quarters to dollars, I'd like you to be able to practice using that by hand, so you can see this is not too much different from what we're about to do. If we have 16 quarters, we have to get to dollars. You just need a fraction here in order to do it. You probably did this in your head already and said, oh, okay, well, that's $4. Well, the dimensional analysis part is how we got there, and that's how I want you to think of this so that we can set up problems. We need dollars, which means we got to get rid of quarters. You have quarters on top, and that's your start. You need quarters underneath the second fraction. And we do have a conversion factor for quarters to dollars, so we don't need to convert twice. And all of you know we have 4 quarters per $1. So 16 times 1 divided by 4 gets us $4. I don't need to do times 1, that one doesn't matter. So 16 divided by 4. That's all we're doing. When this starts to look a little bit more complex, it's like saying, alright, now that we have dollars, we've converted quarters to dollars. Alright, how about dollars to yen? How about yen to Thai baht? It's just adding in additional conversion steps. Let's start with our first conversion, moles to molecules. To learn moles to molecules, we got to talk about moles. What is a mole? A mole is a very, very, very large number of particles. On the graphic organizers, you can see that 1 mole equals 6.022 times 10 to the 23rd. You can sometimes see this simplified as 6.02 times 10 to the 23rd. Either one is fine. That extra decimal doesn't get you much of a change in your answer. That number written out is huge. 6.022. 23rd to the 23rd means I got to move that decimal place to the right 23 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. A new decimal place is all the way here. That decimal is now gone. I need to add zeros to fill this out. This is tedious. This is huge. That's because atoms are so tiny. We can't pick up a single atom, put it on the scale, and tell you what the weight is. We do this with tons and tons and tons of atoms. If we want a certain reactant in our chemical reaction mixed with another reactant in our chemical reaction, we can't do it by the number of atoms like we've been thinking about, or the number of molecules like we've been thinking about when we've been seeing those chemical reaction equations. We need to think about it in moles, in a massive number of those atoms. When we deal with this number of atoms at a time, we can start using units like grams. If we want to use slightly less than this, we can go milligrams, micrograms, but still numbers that we can actually weigh on a scale. So, first one, just to give you an idea of how big this actually is, I want to do some conversions from moles to molecules. So if we have 1 mole of sodium, how many molecules of sodium do we have? Mole, M-O-L-E-S, can be abbreviated M-O-L. Doesn't cut out that many letters, but still we do it. So 1 mole of sodium, if I want to get to molecules, I need, just like we did with the quarters to dollars, I need to convert it by some conversion factor, some fraction that allows me to cancel out moles of Na to get molecules of Na. And that, if you look at graphic organizer and you follow that arrow down, going from moles to molecules, there it is. 1 mole equals that number right there. So that's our conversion factor. We put either mole on the top or bottom, depending on what we're starting with. I want to cancel out moles of Na, so I need moles of Na on the bottom. This is a definition. 1 mole equals that number of particles. So this is always, in the conversion factor, going to be 1 mole. And on the top, we've got 6.02 times 10 to the 23rd molecules Na. This one's an easy one. 1 times that number divided by 1. Okay, it stays the same. 6.02 times 10 to the 23rd molecules. Complicated a teeny tiny little bit. 2 moles Na times a conversion factor to get me to molecules Na. Well, I still got to get rid of moles Na, so moles Na again is going to be on the bottom. Na is standing in for A on your graphic organizer. And again, that's 1 mole Na, and by definition, 1 mole of Na will contain 6.02 times 10 to the 23rd molecules of whatever you're talking about, in this case, sodium. Moles Na cancels out moles Na. We're left with molecules Na, which was our target. 2 times 6.02 times 10 to the 23rd. Sometimes order of operations doesn't mess you up. Sometimes it does. I would get in the habit of just putting the parentheses around it. In this case, it won't. But sometimes with division, it will. So enter that into your calculator, or 2 times this number into your calculator. That will give you 1.204 times 10 to the 24th. Some of you guys will ask, all right, my calculator gives me 19 decimal places. In general, keep the number of decimal places close to what you're given in the question. You'll learn sig figs in physics. For now, just don't make it 9 decimal places when the biggest thing you had here was 2 decimal places to start out with. Just keep it in the same neighborhood. If you see it as a multiple choice, it might be a teeny tiny bit off depending on how you or I rounded, or how a different periodic table rounded their numbers or anything like that, in the neighborhood is good enough. So far we've just been doing, oh, my mistake. Na is actually an atom. Na is just an atom, so this is actually not molecules, this is atoms. Sorry for that, guys, but I don't want to reshoot the video, so I'm just going to cross those out. Molecules are when you have more than one atom involved. So when A is something more than just a single atom at a time. So let's do that with, let's do it with 4. So 4 moles of NaCl. It's not much more complicated. It's just now it's a unit, Na and Cl, but you're not going to worry about the individual things in there because a mole still refers to that number of particles. So again, if I want molecules, I need my conversion factor, and I want to end up at molecules NaCl. So moles are on the top here. I need moles on the bottom here. Moles NaCl to molecules NaCl. Moles NaCl cancels moles NaCl. Fill in your numbers. By definition, 1 mole of NaCl equals 6.02 times 10 to the 23rd. Oh, another one you guys will see. I don't think you can usually enter it into your calculator. It depends on your calculator, but your calculator might return an answer of E23. That means 10 to the 23rd times 10 to the 23rd. 6.02 times 10 to the 23rd. So again, you'll enter this in your calculator. Be safe. Put your scientific notation in parentheses. 4 times parentheses 6.02 times 10 to the 23rd, close parentheses, will give you an answer of 2.408 times 10 to the 24 molecules of NaCl. Moles cancels moles, left with molecules. There's your answer. Make sure you give units. Let's do one backwards. What if we have molecules and we want to know moles? So, we're not going to deal with a small number of molecules. That will give us basically no moles. So you'll see really big numbers with this. If you're doing any of these conversions, molecules to moles, atoms to moles, moles to molecules, moles to atoms, it's going to be a huge number of atoms or molecules because, by definition, a mole is massive. So let's inverse this. Let's stick with NaCl. Instead of moles, we get molecules. NaCl. And let me try to make up a number that will make sense. How about 4.816 times 10 to the 24. 4.816 times 10 to the 24 molecules of NaCl. How many moles is that? Moles of NaCl. So again, we need a conversion factor. So we need to multiply by some fraction to give me my moles NaCl. I know I only need one fraction because now I'm going from molecules to moles. I cross one arrow here. I know I need only one fraction, one conversion factor. Again, I know I've got moles and particles. Particles in this case are molecules. This time, what do I want on the bottom? Well, this time I don't want moles on the bottom because it won't cancel out. I need to cancel out molecules. So I need molecules. moles NaCl on the bottom. And I can convert from molecules to moles, so moles NaCl is on the top, and that matches my target answer. Now fill in your numbers. Again, by definition, 1 mole of anything will consist of 6.02 times 10 to the 23rd molecules or atoms of that thing. And then do your math. Make sure they cancel first. Molecules NaCl cancels the bottom side. Molecules NaCl left with moles NaCl. Good to go. 4.816 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. Careful, they are order of magnitude apart. If I did my quick guesswork correctly, I actually just doubled this. But if you plug this into your calculator and do the math in your calculator, you should get 8 moles of NaCl. Times 6 is 48. Yep. 8 times 6, 48. 8 times 2, 16. Move the decimal. Yeah. Sorry, my brain works funny with math. Alright. That ends the first video that I'm going to post on moles to molecules or molecules to moles. I'll post one more here going moles to grams, grams to moles. Let me leave you with one practice problem for you to do. And I'll tell you when to pause the video and try it yourself. How about if you have 3 moles of magnesium chloride. Set it up, multiply by what to get molecules MgCl. What about, and this will be a nonsensical number, I'm not being too careful about how I make this one up, but if you have 8 point, if you have 9 times 10 to the 26th molecules of MgCl. What conversion factor? One step. Molecules to moles. How many moles of MgCl will that be? So go ahead and pause the video if you wanted to practice that. Take a minute. In a moment I'll continue. Pause now. I'm not going to actually pause. Hopefully you did pause and you restarted this. So I know I need to cancel out moles. Moles MgCl to molecules MgCl. By definition, 1 mole of MgCl consists of 6.02 times 10 to the 23rd molecules MgCl. Moles MgCl cancels moles MgCl. 3 times Avogadro's number, 6.02 times 10 to the 23rd. Put them in parentheses for safety. Will give you 3 times 6, 1806 times 10 to the 24. Down here, I'm going to set it up, but it's a nonsensical number, so I'm not actually going to solve it. To solve this, I know I need, since molecules I'm starting with, I know I need molecules on the bottom to cancel. So molecules MgCl. And I can convert molecules to moles, so I can put moles MgCl on the top. Again, by definition, 1 mole of anything, in this case MgCl, consists of 6.02 times 10 to the 23rd molecules. My molecules MgCl cancels out molecules MgCl. I take 9 times 10 to the 26th, parentheses for safety, times 1, divided by 6.02 times 10 to the 23rd, in parentheses for safety, and that will give me the number of moles. This is 3 orders of magnitude bigger, 23 to 26, so it's going to be a number likely in the thousands, some number of thousands of moles. But don't take my word for it, plug it in your calculator, and see if you get it. All right. Thank you, and happy Saturday. Bye-bye.